Okay, so can everyone see my screen okay? Just confirm, and you should see hopefully the front slide of the presentation. Okay, cool. A few thumbs up. Okay, excellent. Right, so let's crack on. So, yeah, look, appreciate you all taking your time out of your day to come to join a webinar about safety assurance. My name is Damon High, Managing Director of High Speed Rail Solutions. We've got a series of webinars that we're running at the moment. So hopefully, if you like this one, there will be some more that you can look to join in the future. Today, we're going to be talking about system definitions and hopefully how to master those and how they fit into the railway safety assurance process. In terms of what we'll be going over today, so we'll just sort of go over the requirements for systems definitions. So why is it that we actually have to generate them in the first place? We'll go through the content of what's in the system definitions, and we'll go into a little bit of detail of those. Obviously, you know, you could probably spend like a 4-hour workshop just going over all of the key sort of aspects of railway safety assurance. So we'd do the best that we can in the sort of 45 minutes or so that we've got. And then the one thing, so what's the key thing that hopefully you guys can take away from this and maybe some things that you can look to put into action straight away. So hopefully nice and simple journey that I'll take you on through the next sort of 45 minutes or so. So initially, we'll look at the requirement for system definitions. So where's that come from? And a lot of you will probably recognise the flow on the right-hand side, the process. So that risk management process that is on the right-hand side, that has come from in the UK and Europe, that has come from the Common Safety Method for Risk Evaluation and Assessment, so the CSM regulations. Oh, need another 50p for the meter. And if some of you are from Canada, I know some of you have joined from Canada as well, so that same risk management process, that has also come from the Canadian Method for Risk Evaluation and Assessment for Railway Systems, so the CMREA. So CSM, UK and Europe, and CMREA, pretty much identical, same risk management process. The blue box indicated there is where in the process system definition is required. And for any of you that have also come across CENEVEC standards, so things like 50126, 50129, the requirement for a system definition document is also captured in there. Now, those regulations and standards, so in the UK and Europe, it's a regulation, so that means it is a legal requirement that we have to produce one. In Canada, CMREA, it is a standard, so technically it's not something that has to be applied. But for those of you working on Metrolinx projects, for example, the use of CMREA and therefore the need of system definitions is now more frequently being written into like contractual requirements. The system definition, as per those standards and regulations, state that you must cover these 7 items on the left-hand side, but it doesn't really go into the detail of what exactly you need to talk about for each of those headings. So we're going to try and break that down and go into that in a bit more detail over the next sort of 40 minutes or so. And just as a bit of a reminder to those of you that might not sort of use it too often, that risk management process that was on the previous slide, so that applies whenever we're looking to make a technical change to the railway, an operational change, or also an organisational change. The majority of the sort of change that we make to the railway is very much technical and very therefore closely linked with the operational element. So if we're building a new railway, if we're introducing electrification, things like that, then obviously there's very close links between those two. But also if we're doing an organisational change. So again, on a project we're working on in Canada at the moment, they're looking to change maintenance, railway vehicle maintenance and operations from Metrolinx and Alstom over to a new train operating company called On Express Operations Inc. A large portion of that is organisational change. A large element of it is people changing the logos that they're going to be wearing. Obviously, a bit more into it than that. But again, organisational change required of CSM, CMREA, and therefore we need to produce that system definition document as well, whatever the type of changes that we're working on. However, instead of diving straight into a system definition document that dives straight into system objective, generally we want to try and include some sort of introductory section. We kind of want to set the scene for the rest of the document that we're producing. So in that introduction, we want to look at the purpose of the document. So what standards, what regulations, what company standards are we looking to comply with as a result of producing this system definition? So within the UK environment, it isn't just about complying to the CSM regulations. It's also making sure we're complying to Network Rail Company standards, guidance documents issued by the RSSB and the OOR, OOR being our National Safety Authority in the UK. And then from a Canadian context, the CMREA, but then also Metrolinx company standards as well that have been produced. And often those company standards talk about how they want to apply CSM, CMREA into their own railway infrastructure environment. So what's the purpose? So therefore, what standards, regulations are we looking to comply with? What's the scope of the system definition? Now, obviously, we then get into more detail of that as we move later on into the document. But again, this is trying to set the scene of, well, is this a program-wide system definition? Is it a project system definition that then forms part of a bigger program? You're trying to set the scene as to whereabouts in this sort of railway assurance puzzle does this particular document sit. For example, Great Western Electrification projects in the UK, we produced a program-wide system definition document, and then we had lots of individual route section system definition documents as well that fed in to that overarching program document. So again, we just try and look to make sure that we can fit all of the pieces of the puzzle together and we're clear on where this sits in that chain, in that hierarchy. What's the significance decision? So again, whether or not it's program or project specific document, CSM, CMREA, you have to go through a process of understanding, is this change that you're making significant or not? And if it is, then that means that we need to go and appoint an independent assessor, so an assessment body or an independent safety assessor, again, depending on what jurisdiction you're working on. So we want to understand early on in this document, is our project significant or not? And therefore, which external body have we appointed to essentially check our work? And then some more common things that we'd be used to referencing in our documents as well. So abbreviations and references, but also how often are we going to review the document? So it might be that we review it every 6 months to make sure it's up to date, or are we going to check it at the end of each phase of the life cycle as well? Because what we need to do is make sure that this system definition is a live document that we keep up to date all the way through the process. Because ultimately, if we've got something that we produced 3 years ago that then looks very different to what we've actually gone and built out on track, then those independent bodies are going to have a little bit of a field day, just sort of being able to try and make you try and justify how you think you've looked at all of the hazards associated with your change if you can't keep your system definition up to date. Because the system definition is really, really key in trying to bound the scope of your risk assessment activities. Okay, so if you can't clearly articulate it in this document, then those independent bodies are going to have some sort of nervousness around the fact, have you identified all of the hazards associated with the change that you're making? So from a system objective perspective, these are the types of questions that we'd look to answer. So what's the business reason underpinning the change? Are we looking to increase our capacity? Is it about line speed improvements? Why is it that we're doing what we're doing? And again, so we've got a diagram on the right hand side. So that's been taken from Midland Rail Hub program, so Network Rail document that again just tries to help again diagrammatically sort of articulate some of the changes that we're making and therefore some of the sort of improvements that we're looking to achieve as a result of the program. So really, what's the purpose of the change and why are we doing what we're doing? Actually, interestingly, on that last bullet point, so what other changes might need to take place before our business benefit can be realised? So actually, on Midland Rail Hub as a programme, there were actually other pieces of work that were being delivered by other parts of the organisation that actually would need to be delivered prior to Midland Rail Hub then being able to implement some of their interventions and some of their changes. So again, we need to sort of make those links in here as well, just again to help understand how the railway as a system will be fitting together as we get to the end of our projects. Systems, functions, and elements. So that's when we start to get into providing a lot more detailed descriptions of the exact changes that we're making as a result of our project. So again, a large part of it could be very much technical and operational orientated. So we might want to talk about each of the changes that we're making to the railway constituent subsystems. So that's a sort of European interoperability directive phrase. But again, for a number of you that even aren't in the UK or Europe, you'll understand the term, I'm sure, especially when we start thinking about trackside or onboard command and control signalling systems, energy, so the electrification, traction power systems, infrastructure. It's quite a large beast that because we're talking about civils, we're talking about track. So this is where we try and break down logically each of the elements and start getting into a lot more detail as to describing the actual changes that we're making. Some of the things that we therefore need to consider as a result of that are we introducing any new or novel equipment? So we could be introducing new interlocking, computer-based interlocking systems, new software versions that haven't been used before. It could be the first time that we're implementing ETCS on a particular stretch of railway, and the first time that that new system is got to integrate with an interlocking. So is there any new or novel equipment? Because again, if we can describe that, if we can make that clear, then that helps us focus some of our efforts when we get into trying to identify the hazards associated with this change. Are there fewer assets, more or fewer assets, more or fewer operational maintenance staff? Are we actually having an impact on some of the competencies? We've worked on a project to do with a large change in the Midlands area where we're introducing new types of level crossing. Well, no, sorry, let me clarify. It's level crossings that are used all the way through the country, particular type of level crossing, grade crossing. But actually, in this particular area, those maintenance staff were not used to having to operate, to maintain that type of crossing. So again, that's something that we recorded in here so that we could have the right attention on that as we get into try and identify what hazards could be associated with it. We need to think about stage works. So while CSM is predominantly focused on what the final configuration of the railway is going to look like and what the hazards are associated with that railway in its final configuration, obviously, if say we're introducing electrification, 100 miles of electrification, we're not all going to turn it all on in one go right at the end. If we're introducing a new signalling system, we're not going to introduce it and turn it all on right at the end. So we do need to understand the impacts of stage works on the process. So we do need to include some element of description around those stage works and how each of these systems and operations are being impacted as we go through the process, as we go through that life cycle. A lot of system definitions we see might make a statement in there that talks about that we need to think about normal, degraded, emergency modes of operation. But again, if we can, let's try and get into a bit more detail to actually understand, okay, well, what are the types of degraded and emergency modes of operation we need to think about? Electrification, some maybe degraded mode, you might have a dewirement. You might have wrongly routed an electric train up a non-electrified piece of track. How are we dealing with that? we need to capture that to understand those different types of degraded modes, so then we can think about it again as we get onto hazard identification. Emergency modes of operation to do with the station might be fire, for example. So if we can give an idea in our system definition as to the different types of degraded and emergency modes of operation we need to think about, it just makes the last bits of that risk management process, the next stages of that risk management process, a lot easier to navigate, as opposed to trying to think on your feet when you're in a hazard identification workshop. A system definition, ideally, if we're using it properly, could almost be the single source of truth that any person in the project could look up to understand the change that we're making. All too often, it is produced by safety assurance people because it sits within a safety assurance framework. But if we use it properly, it can be used by other people to get up to speed with what we're doing, and therefore it can refer out to all of the other key project documentation that might be relevant. So potentially concept of operations documents, requirement specifications, user requirement specifications. It can be that guide that points us in the right direction to all the other things that we need to think about. So that's system functions and elements. System boundary and physical and functional interfaces. So within CSM and CMREA, they are two separate bullet points on that list that we had up earlier. But because there's so much crossover between the two, generally we capture all of it, capture all of the relevant information within one section within our system definition. Picture paints 1,000 words. So again, as you can gather through the title, if we can sort of try and articulate this through pictures, then it's just going to help us understand and help us bound the scope of our risk management process. Can I just double check, people? You still hear me all right? Still see my screen? I think I just heard a funny noise, like it's something dropping off. I'm just looking at my phone. Like, yeah, okay, sweet. Things are. People seem to be able to still hear and see. Okay, brilliant. What I've got on the screen here, to just again as an example, so this is the Great Western Electrification Program. So this is the route that we're electrifying, and what we're trying, and I'll talk you through these various sort of codes and color codes in a minute, but this will hopefully also demonstrate why we need to keep things live as we go through the life cycle of a project. We've got the original route all in reds, highlighted in reds. That was all the stuff that we were hoping to electrify when the program started. But as you can see through the crosses, they kind of run out of money really. So therefore we weren't electrifying up to Oxford, and then we weren't able to electrify past Chippenham all the way down to Bath Spa on the left-hand side and up to Bristol. So there was large chunks of railway that actually we then didn't electrify. We had to keep our system definition up to date, because otherwise, again, independent assessor looking at this, they're not going to sort of understand that unless we keep this document up to date as we go. Now, the way that this particular program was broken up, it was broken up into route sections. So again, going back to the point that you're not going to turn on 100 miles of new electrification all at the same time. So they broke it up into route sections to try and help break it up into chunks to deliver it. So a lot of our system definition documents, so we had a program-wide one, but then we had individual route section system definitions as well. Awesome, makes sense. Okay, we get into a lot more detail for the individual route sections ones that you don't want to capture just in one big program deliverable. You're having to be updated all the time as things change. As we were moving from right to left, as we were electrifying it, everything was working out fine. As we were turning on a bit of section, the energisation areas aligned perfectly with the route sections. As we started to move from Swindon over towards Chippenham, over towards Cardiff on the left-hand side, unfortunately, it didn't get as neat. We were finding that the energisation area didn't neatly align with the route section area, so there was a gap. So any gap you can see around here, hopefully you can see my cursor, any gap you can see here between the blue and the reds indicated where things weren't neatly lining up. And therefore, because we'd based our documentation on route section, technically we'd be turning on more parts of the railway than we had accounted for in our route section documentation. So technically we wouldn't have been able to demonstrate that these gaps between the red and the blues would have been safe. The bits between the blue lines would have been good, but there is a gap in our analysis between the route section and the energisation event. So halfway through, we had to change our approach to not talk about route sections. We had to talk about energisation events. So instead of having route section system definitions, we changed to having energisation event system definitions. And that's what we then had to base all of our following hazard identification. We had to redo that. We had to update our safety justifications, our submitting strategy. It had a big impact. So we had to keep all of these documents up to date as we went through the process. And I guess really, I suppose a lesson learned from that as well is that if we can try and get an idea as to how the system is going to be commissioned, what does that end testing and commissioning strategy look like, then hopefully we can feed that back into our strategy as to how we generate these documents in the first place as well. So some of that, it's not too easy to find out, especially if you're on a large and complex program that's going to be going on for a number of years. But it's always worth asking. Sorry guys, if you're on, if you wouldn't mind just muting yourselves as well, that'd be awesome. Thank you very much. So that's sort of helping from a sort of geographic perspective. We've got some other sort of diagrams in here that we can use. So we've got examples of some Metrolinx track maps. We've got some Network Rail track maps. You can't really see the detail too much on those, but these help identify other areas of railway, other assets, access points, footbridges, level crossings. They help identify a number of other assets that we will need to eventually start thinking about when we use this system definition to form the basis of our hazard identification activities. So again, trying to describe this in just words would be a nightmare. So if we can use some diagrams to help make this clearer, that we can then use during those workshops to identify hazards, then that would be fantastic. Diagrams as well, not diagrams, tables as well that help us understand more about start and finish mileages, signal boxes that might be en route. Again, it just helps bound that scope of our risk assessment, risk management activities. Other types of diagrams as well that again would be worthwhile. We might have system architecture diagrams, so like the one on the left-hand side, or we might have system context diagrams. So again, there's so much information that we're trying to get across, it's hard to sort of necessarily see all of it, but it helps us understand how our different technical subsystems might be interfacing with each other. And again, we can sort of go around each of those interfaces to understand how the change might have an impact on various hazards that we need to record. And system context diagrams help us, again, understand they help provide prompts between how there are different interactions between our subsystems as well. Again, really good sources of information that we can use to help us identify hazards. Now, just because we're using these diagrams and we're capturing them in a safety assurance deliverable, a system definition, it doesn't mean that it's safety engineers that are producing all this material. This information is being produced by other great people in the project. So whilst a project might want the safety team to generate a system definition, because technically it's a safety assurance deliverable, that cannot be done in isolation. Those people generating this document need to go and speak to not just discipline engineers, like a signalling engineer, a track engineer. They might need to speak to project managers. They might need to speak to sponsors to understand interfacing systems and projects. Lots of information needs to be gathered from lots of other people. This is not just a safety assurance activity. And again, something slightly different as well. Who do we need to think about from the human perspective? So sorry, whilst the one in the middle, sorry, is still looking at the subsystems that we need to think about. So what are the subsystems that our overall program or projects might be impacting with? So that might help again visually. We need a lot more text around it, obviously, but visually that might help. But yeah, we need to think about the human interface as well. So who are those railway actors that we need to think about? So operations and maintenance actors, so signallers, electrical control room operators, station facility operators. Apologies, some of those acronyms will mean something to the UK audience, but maybe not as much to those of you not from the UK. So basically, train operating companies, maintenance teams, all of those people involved in operations, we need to think about how our change to the railway might be impacting them. But then those external to the railway as well. So members of the public, highway users, footpath users, emergency services. If we're making a massive change to the layout of a station, well, actually, we need to involve emergency services in that, because if they turn up to an emergency and entrance exits are all in different places, they haven't got updated emergency plans, then that in itself is going to cause issues in the future. So if we can think about all of the systems, all of the people that we're impacting, then again, that will help us identify any hazards that we then need to manage and close out as we move through the life cycle of the project. Next part in the system definition list, we talk about system environment. But what we need to think about there is that this isn't just about the weather. So a lot of system definitions we see are just thinking about the weather, because to be fair, the CSM and CMREA does include these items here in brackets after it uses the term system environment. So, yep, we do need to think about things to do with the environment. Are we making a change that's on a floodplain? Do we have any particular sensitive equipment or facilities like hospitals nearby that our systems might interfere with? But equally, we need to think about the operational environment. So that project I mentioned a bit earlier in Canada, where they're looking to move operations and maintenance activities from Metrolinx and Alstom over to On Express Operations Inc., they were having to change the people that were going to be interacting within the control center. So again, we need to capture that. Are we therefore also having to change screens, desk layouts, the actual layout of the control center in its entirety? Where are people going to be sitting, from what sort of organization and what sort of role? Because again, that would have an impact in terms of safety critical communications. We need to make sure we capture that type of information. And again, very early days in the project, we might not know that level of detail. As we start getting into more detailed design activities and things like that, that is going to become clear. And then we need to keep, again, our documents up to date. There could well be changes to the regulatory environment that we need to think about as well. Again, if there are, we need to think about and capture that sort of information here as well. So that's about system environment. It's not just about the weather. We then have to think about existing safety measures and safety requirements. So the idea of this is that if we know what existing safety measures that we've got in place, we can then determine whether or not they are still suitable based on the change that we might be making to the railway. So we've got a grade crossing on the right-hand side. The types of existing safety measures that we would talk about there are to do with the road markings. We'll be talking about barriers, the bells that are being used, whether or not it's a manned crossing. There's lots of existing safety measures. The operation sequence of it, and timings and strike-ins and things like that. There's lots of existing safety measure information that we would look to include as part of that work that we might be doing to a grade crossing. Again, from an electrification point of view, we've probably already got line side fencing or barriers that stop trespass of people coming onto the railway, which is still a good thing, right? Introducing 25,000 volt electrification systems, we still want to make sure we're keeping people off the railway, so they're not going to come into contact with it. However, if we've got a whole load of metal fence along the railway and we're now introducing 25,000 volts, we now need to think about, well, actually, is it still suitable? Do we now need to think about earthing and bonding of those metal fences next to the railway? So it's things like that that we can think about if we start to list out those existing safety measures, and we can determine their sort of continued relevance or any changes that we therefore might need to make to it. As we go through the risk management process, as we've started identifying our hazards, as we've started to come up with safety requirements which we need to meet to mitigate those hazards that we've identified, what CMREA, CSM talk about is capturing those safety requirements in the system definition. Fine, not an issue with that, but actually there is a bit of an issue with it. I think that's fine when you get to the final revision of your system definition, when you've produced that after commissioning activities. But in terms of keeping that live all the way through the process, it's far easier to capture those safety requirements in your hazard record. System definition, you might not need to touch it for every 6 months, something like that. Your hazard record, in theory, you're looking at that on a day-to-day basis. It's much easier to capture your safety requirements, a consolidated list of those in your hazard record document. So in your system definition, you probably just want to go and refer out to the hazard record where they can go and find all those safety requirements as well. Common practice, use it all the time. Generally, any sort of independent body doesn't really have an issue with that. They just want to see in the main that you are capturing your safety requirements and managing those and keeping them up to date as you need to through the process. Okay. So from an assumptions point of view, the main ones that we're obviously interested in are those that are going to impact the risk management process. So you might, and again, different projects vary. So some projects might have an assumptions log, an assumptions register. Whether or not they keep it up to date, I don't know. But that could be a good source of initially finding out some assumptions and thinking about, are there any there that we need to think about that could have a safety impact? If we don't validate that assumption to be true, could that have a safety impact? So we've got some ideas of those on the right, at the bottom right of the slide there. So if we look at number 3, that goes back to competencies of staff. So as I mentioned, on where we're introducing that level crossing into an area where those staff hadn't operated or maintained that type of crossing before, if we had made this assumption and we hadn't gone and validated it, potentially we may have missed the fact that there could be hazards associated with maintaining that new piece of level crossing. It probably would have been something that would have been brought up in a hazard identification workshop. We probably would have captured it there. But if we have made that assumption here, then we have to go and validate it. And then again, that helps us make us understand, is there a risk there that we may or may not have missed? Again, it's difficult. You might very early days in the generation of your system definition, you might have some very high level assumptions that you've captured in your system definition. Excuse me. But as per the safety requirements, it's very common that any assumptions that you want to validate that could have an impact on your risk management process, it's very common that those assumptions are also captured and managed in your hazard record as well. Whether or not they're all tied up to hazards, whether or not you've got a separate assumptions tab or assumptions module that you need to go through, Again, each project is a bit different, but the day-to-day management of those assumptions is generally captured in your hazard record as well, like your safety requirements. So that is a very quick run through of why we need to generate system definitions, the information that's required to be captured in the system definitions from a high level, what the standard, what the regulation wants, to hopefully give you a bit of a flavour for the types of information that we want to include in there to make sure that we can bound that scope of our risk assessment so that we can then usefully use our system definition as we move into the next phase of identifying our hazards. So hopefully that's given a bit of a warm flavour for that. I also said that we'd talk about the one thing that I think you should take away from it. I couldn't actually whittle it down to one thing. I get a bit carried away with this type of stuff. I've actually come up with 4, and there are probably more as well. But really, hopefully some of the key points that you'll take away is that without a detailed system definition, it's hard to convince the stakeholders that we've identified all of the foreseeable hazards. So if we don't go into much detail, if we don't sort of include diagrams, provide detailed text to the changes we're making to the railway, it's going to be hard for us to convince those independent safety assessors that, yeah, we've done a good job identifying all of our hazards, even though we don't know what we're actually delivering. Yep, fine, we've identified all our hazards. This isn't just a safety assurance activity. Input needs to be given from the projects and engineering community, probably the sponsorship community as well, to make sure that we do have that detailed system definition that we can use. Mentioned it quite a lot during the process, but we need to make sure it's up to date to reflect the changes to the project scope, because again, on large and complex projects, the scope is going to change, and that scope change therefore does impact our hazards that we've identified. It could mean that we've identified hazards that are no longer applicable because of the scope change, or it could mean that we've now got a gap and we therefore need to go and run another workshop to see, okay, is there anything else that we need to think about here that we might have missed because of this new scope or due to this change of scope? And again, mentioned it earlier, but if used properly, the system definition doesn't just have to be a safety assurance deliverable. It can be used by the wider team to make sure that everyone is on the same page as to what it is that we're doing and why we're doing it. So that is it, as it were, for a sort of whistle-stop tour on system definitions. We have 45 minutes. We've got a couple of minutes shy of that. I will make sure that we get the set of slides and the recordings. We'll get some links sent out as soon as possible, so that we can so that you guys can use that as a resource, hopefully a useful resource at some point. But I'm happy to sort of stick around and answer any questions that anyone might have. So for those of you that need to go, obviously, I appreciate you taking the time out. We've got some more webinars coming up, so please do sort of keep an eye out on the website, sign up to a few more. Any feedback is gratefully received. But yeah, for those of you that might have any questions, I'm happy to go through and answer them as best I can. Or I have sent you to sleep.
No, he's still awake.
Sweet. Good stuff. Thanks, Colin. You'll recognise some of those diagrams.
Yep.
Okay. Well, look, my email is going to be on the slide deck. I'm on LinkedIn, all that good stuff. If you've got any questions that you're too shy to ask now, but anything that you want to touch base on, anything you're not sure about still, please do feel free to reach out. Okay, more than happy to help. More than happy to try and make sure that the quality of these system definitions are as good as they can be. So it doesn't look like there's any. Let me just quickly check the chat. Okay. No, thank you, guys. Appreciate that. So yeah, unless there's no questions, anyone, I will let you be. So have a good rest of your evenings and afternoons wherever you may be. So thank you very much for your time. Cheers. Take care.